Good evening, Namaskara, Vedantu Karnataka students. Nama Hesru. Yes, Captain Shreyas. This is your Captain Shreyas on the Vedantu Karnataka channel. Bega subscribe ಮಾಡಿ, ಬೇಗ like ಮಾಡಿ. ಯಾಕಂದ್ರೆ this is the most important session for all of you. The top 30 questions to score 70 out of 70 in your second PU examination. So ಬೇಗ like ಮಾಡಿ, ಚಾನೆಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಇದು ಟೆಲಿಗ್ರಾಮ್ ಚಾನೆಲ್ ಇದೆ. ಅದಂದ್ರ ನೀವತ್ತು all the updates, all the important notifications, all the upcoming sessions, timetable, PDFs, everything will be shared, and also the session PDF ಬೇಕಂದ್ರೆ wait ಮಾಡಿ, because after the session we will be sharing the PDF of that session. All right, so let's begin. Nice to see all of you. Hi Sojanya, hi Manoj, hi Varija, Raju, Niharika. Nice to see all of you. uh, yes, where are you from? Namma uru Bengaluru. Where are you guys from? Let me know quickly in the chat box so that I also know where and all students are watching us from. Okay, so important, very likely questions. Okay, so here we go. Let's start with the session. Okay, first we have the objective type of questions. The electric field near a sheet which is having a surface charge density is given by which formula? Bangalore to. Oh, high five, alligator. Aishita, hello. Hi, Jayant. Good evening. Geeta. Yes, I do remember you. Nice to see you back. Hi, Srinivas. Hi, Varija. Nice to see you guys. Udupi, Raichur, Bengaluru. Wow, nice, super. Okay. So whenever you have a charged sheet like this, electric field near a sheet, the electric field will go this way also and this way also. It is uniform in nature, and the value, because it is going two ways, so sigma by 2 epsilon naught, 1 2, this side, that side, so two sides, so that's why 2 will be there, and that is why the answer will be sigma by 2 epsilon naught, and is perpendicular. Normal andre idu perpendicular ide. Yes, this is perpendicular. Yes, very good. D. Awesomeness. Moving on to the next question. Bidder, Rockstar. Wow, super. Drift velocity varies with the intensity of the electric field as per the relation. What's the relation for drift speed and the electric field? Okay. What's the formula? Yochna Madi. Yes, the drift speed formula andre electric field into electron charge divided by mass into relaxation time. So drift velocity related to electric field directly proportional. Yes, directly proportional andre option A. Very good. Very good. Many of you are getting the correct answer. No, it is not B option. Okay. So ಸ್ವಲ್ಪ correction ಮಾಡಿ. It is going to be proportional to electric field, inversely proportional to mass, directly proportional to relaxation time, as well as the electron charge. What is the unit of the intensity of the electric field? Electric field, no problem. Whatever mistakes you do here will help you remember those things in the exam. See, if you do mistakes now, 100% you will remember, and you'll be like, yes, sir had told me. Oh, in the mock test I had done this error. 100% you will not repeat it. Okay, so that's why you should attend all these sessions. Electric field, the units are either Newton per coulomb or volt per meter. Newton per coulomb, remember the formula, electric field is force per unit charge, and electric field is also delta V by delta R. Delta R is measured in meters, voltage is measured in volts, charge is measured in coulomb, force is measured in Newton. So Newton per coulomb or volt per meter. This is voltmeter. So this can't be C, it has to be option A. Super, very good, very good. Vaini Giant, Varija, awesome. Alligator, super. Keep on spamming the answer. I love it when you give the answers with so much enthusiasm. Shreyas sir loves it. Thank you so much. In N-type semiconductor, the electron concentration, N-type, N as in negative electron. So electrons will be more everywhere. What will be less? The holes will be less. Yes. And because of that, number of donor atoms, number of acceptor atoms, number of both type of atoms, neither number of acceptor nor donor. These electrons, where do they come from? Those atoms which have that extra electrons. Extra andre, yes, donor. Acceptor as in they need electron as in the holes. So that is basically donor. That is basically donor. Holes. Holes means there is a vacancy. So vacancy means they want to accept. They want to accept. So P type has vacancy, acceptor. A donor means electrons, that is N type. Understood? Donor N, donor N, donor N over here. Okay, right. Moving on to the next question. The incident photon involved in the photoelectric effect experiment, the incident photon in the photoelectric experiment completely disappears, comes out with more frequency, comes out with less frequency, comes out without changing the frequency. So imagine this is your metallic surface, and from here there is a photon. This photon, which is basically light, falls onto it. What happens is electrons are ejected out. Electrons are basically ejected out. So if electrons are ejected out, what happens to this particular photon? This photon is basically absorbed over here and it transfers the energy to the electron. That means it disappears. It is absorbed. No, it does not come out with increased frequency. B is not correct. It disappears because it gets completely absorbed. Remember that. In fact, the equation also is like this. Energy of the photon is minimum energy required to take it out, plus the remaining goes as kinetic energy of that electron. That is the formula. Okay. The electron depletion region. I will explain it to you. 1 second on this slide. See, I'll tell you what it is. Electron depletion region. This is, let's say, um, your PN junction. This side is, let's say, P. This side is basically N. P means what? There are vacancies. Vacancies means there are more holes. Holes are there. Holes are there. Holes are there over here. So these are basically more holes. N means what? Electrons are there in excess. So these are excess electrons. N side has more electrons. More electrons as compared to the holes. Is that right? Donors are there here. Here acceptors are there. So these people want food and these people have that food. Or think of it like this. These are like pretty champas over here, and these are like handsome pandus. This is like N for Natasha. Some girl named Natasha is there, and P for Pandu is there. Imagine like this. Okay. So Pandu needs a girlfriend. Girlfriend beku. Okay. This Natasha boyfriend beku. What will happen? Okay. Whole can't move. Pandu is, let's say, fat panda types. Okay. Pandu is very fat. Pandu will be like, I can't move. So these electrons, this Natashas, they will immediately jump over here. They will immediately jump over here. Okay. But the moment they start jumping, what happens is this side will now become negatively charged. Yes, this side will now become negatively charged. And because the electrons left, this side will now become positively charged. So can you see, because of this negative charges, more Natashas can't come. These Natashas, they are going to act very weird. They will be like, hey, we are already meeting these Pandus. They will be like, more Natashas, more Champas, more pretty Natashas not needed. And these positive charges will also prevent them from going here. Okay, they will attract these electrons even if they try to jump over. So in this particular region, what you see, this zone is then called as the depletion region. Why depletion region? Because here whatever electrons were there, they moved on to this side. They covered up the holes. So they have depleted the holes and they have depleted the electrons, thereby creating an electron charge on both the sides. And this creates a barrier. This acts like a wall to prevent more electrons to jump. That is what it is. Okay. I hope, Jayant, this is clear. Yep. You cannot say P is positively charged. P has more accepting tendency. It is not positive. N is not negative. N has more donating tendency. That's all. Okay. Moving on. Which atoms combine together during fusion reaction on the sun? Very simple. Fusion. What happens? Hydrogen meet and they become helium. So what is that? Hydrogen and helium atoms, they basically combine together and they undergo the fusion reaction. Yes, is it like a capacitor charge storage? Yes, exactly. This one is like a capacitor. You can think as if this is like the positive plate of the capacitor. This is like the negative plate of the capacitor, and there is an electric field in this region. So this has higher voltage and this has lower voltage. Definitely there is a voltage difference, just like a capacitor. Definitely. Okay, moving on to the next one. Light, when it falls on a sensitive material and if the intensity is doubled, what happens to the electrons which are being ejected out? So if more light falls, intense light falls, what happens, guys, my dear warriors? Quickly think and tell me in the chat box right away, right now. Yes, then you will see the number of electrons will also, not electrolysis, electrons will also double, because current is directly proportional to intensity and current is dependent on the number of the electrons ejected out. This intensity, when it is doubled, obviously the number of electrons will also be doubled. Hence, that should be the answer B for Basava sir. Yep, your Basava sir. He had taken an amazing class yesterday. Your biology top 30 questions. I hope, yes, you have seen that class. Yeah, please note Beku, because it's an awesome class and the next classes are also going to be scheduled on Monday, Tuesday, etc. So please watch it, okay? Path difference between coherent waves for constructive interference. See guys, whenever the interference is constructive and you want maximum intensity or amplitude, the path difference must be n times of lambda. And if you want destructive interference ಬೇಕಂದ್ರೆ minimum intensity ಬೇಕು, ಅದಂದ್ರೆ delta x should be odd times the lambda divided by 2. ಈ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನ್ ಬೇಕು? Path difference for constructive, that means option A, n lambda. Option A. Got it, my dear students? Everybody? Yep. Awesome. Awesome. And if you have not yet subscribed to the Vedantu Karnataka, Namma Karnataka channel, please subscribe it right now. And you hail beku your batchmates ge, friends ge, relatives ge, cousins ge, because this is a super channel for all of you for PUC preparation, KCT preparation, and COMEDK preparation. Now we are going to heavily focus on PU second year. KCT sessions will continue, okay, question series, etc. But after PU, then we'll be focusing on KCT and then COMEDK, okay? So all super questions will be done over here. Sakkataga questions ಬೇಕಂದ್ರೆ ಬೇಗ subscribe ಮಾಡಿ and like ಮಾಡಿ. YouTube will understand that you are interested in cracking this examination and it will recommend you such videos then. The expression for the fringe width. What is the expression for the width of the fringe? Yes, beta is a lambda wavelength into distance from the screen to the slit upon the distance between the two slits, small d. Lambda d by d, I think that is option C. Yes, C for Capto, C for Captain Shreyas. You can see it. C for Captain Shreyas, Captain Shreyas. And that's my handle everywhere, Instagram, Telegram, everywhere, Twitter, you name it. Due to atmospheric refraction, the length of the day increases by about, this is there in your NCERT. So this is a direct theoretical question. Either you know it or you don't know it. Well, take a guess. Is it 2 minutes, 1 minute, 4 minutes, 3 minutes? It changes by around 4 minutes. Yeah. Due to the refraction, what happens is the length of the day is affected by roughly around 4 minutes. That's a lot. Just imagine 4 minutes is not small to be ignored, not very big that it affects us so much also. The correct expression for the displacement current, remember, this is a question from electromagnetic waves, there are two types of current. Conduction current, which happens because of the flow of the actual charges. This is the flow of charges. And the other type of current which is there is basically called as the displacement current, which happens due to the change in electric flux. Due to the change in the electric flux. Yes, what's the formula? What is the formula? Epsilon is there, d phi by dt is there. Correct. This phi over here represents the rate of the change of the electric flux into epsilon naught, which is permittivity, will give you the displacement current. Many students get confused whether it was epsilon naught or mu naught. No, it is epsilon naught. And then the modified formula becomes, for Ampere's law, cyclic integration of magnetic field into the length which you cover is equal to mu naught into here you have conduction current, here you have conduction current, plus then you have the displacement current. Displacement current is permittivity into d phi by dt, which is displacement current. That is the formula. So you can see it cannot be mu naught, because mu naught will become mu naught square. No, rather it is mu naught epsilon naught d phi by dt when you open up the brackets. Okay, so that is how you can remember it. Ampere's law. Magnetic field can be produced by, how can you produce magnetic field? If you want to produce magnetic field, static charge, neutral particle, all of this, no, moving charge. So when you take a wire, what happens is inside of that there are, let's say, charges. If these charges are under motion, then it will produce a magnetic field around it. Current carrying wire produces magnetic field because of moving charges. So hence the answer should be option A. Correct. Very good. Awesome. Varshita, Pranav, Jayant, Alligator. Uh, can I send a list of all the derivations? Okay, I will see if I can make a video and only upload it directly. Let's see if we can do it. SI unit of magnetic susceptibility is SI unit of susceptibility. If you remember, there is a formula, relative permeability is 1 plus susceptibility, and relative permeability is a dimensionless unitless number. Even this is dimensionless unitless number, that is relative constants. Okay, relative, it is a ratio, it is not having any units or dimensions, so no units for this. Yep, no units. Yep, very good. Option D will be the correct answer. Okay, shall we move ahead to the next question? Which of the following circuit exhibits maximum power dissipation? Maximum power. Purely inductive, purely capacitive, purely resistive, none of the above. Power is Vrms into Irms into cos phi. Into cos phi. If you want to make the power maximum, cos phi should be maximum. That means phi should be 0, because cos 0 will be 1. Maximum value of cos is 1. So if you want that, obviously the voltage and the current should be in the same phase. Only then this can happen, and this happens when it is resistive circuit. It is basically resistive circuit. Anything else, inductance or capacitance, there will be a phase difference between voltage and current. Yes, purely resistive circuit. That is the correct answer. Which of the following is the wrong? Be careful. Which of the following is a wrong statement? Okay, come on, my dear students. EMF can be induced between the ends of a straight conductor by moving it through a magnetic field. Self-induced EMF by changing current in a coil is always trying to decrease the current. Inserting a iron inside a coil increases its coefficient of self-induction. According to Lenz's law, the direction of induced current is such that it opposes the flux change that causes it. I think it is very obvious. The wrong thing will be inserting an iron core in the coil increases its coefficient of self-induction. The self-induced EMF produced by changing current in a coil is always tending to decrease. No, this is wrong, guys. I mean, this should not be the right answer. This B should be the wrong answer. I'll tell you why. See, EMF can be induced. This is basically on motional EMF. Motional EMF. Motional EMF is magnetic field into length into velocity. BLV. Is that right? Yes, BLV. According to Lenz's law, the direction of the induced current is such that it opposes the flux change that causes it. Yes, this is exactly what Lenz's law is, and it is based on the conservation of energy. Conservation of energy. So this is also correct. This is also correct. Inserting iron. Iron is basically ferromagnetic in nature. Iron core is basically ferromagnetic in nature. So what happens to the self inductance, that is mu naught, okay, into relative permeability into n square into L into A. So if relative permeability increases, inductance also increases. So therefore C is also correct. This is wrong. I'll tell you why. The changing current, when you change the current, the coil always will decrease the current. The self-induced EMF produced, okay, by changing the current will always tend to decrease the current. That is wrong. It may decrease or increase depending on what is happening. If the change is positive, it will try to decrease. If the change is negative, then it will try to increase. So the change can be positive or negative. Hence, B option is the wrong one. Got it, my dear students? B option is the wrong one. Why? Welcome, Niharika. You're from the Sankalp batch. Oh, nice, Niharika. I'm so happy that uh, you are attending the KCT classes because for Vedantu, you know, it means a lot because we are based out of Bengaluru and we want to actually, do everything possible for all our students here. And we realize that not any edtech or any major coaching is doing much, especially on YouTube or even online. We hope that we will have Sankalp like batches in KCT, ComEdK and PUC also in the forthcoming years. All right. So thank you very much. Make sure all your friends are also watching this channel. All right. Moving on to the next, and here we have filling the blanks. Filling the blanks. Okay, these are the options given. They will fill in some of the blanks. Molecule possessing permanent dipole moment is called dash molecule. Net magnetic flux through any closed surface is dash. Rotating vector used to represent AC is called. Wavefront is a surface of constant what? In interaction with matter, light behaves as if it is made up of packet of energy called what? Okay, I think the easiest one. Rotating vector used to represent alternating quantity is called basically what? Phasor. This is basically going to be phasor. Okay, phasor part is done. Okay. Then next, a wavefront is a surface with constant what? Phase. Yes, a wavefront will have all these particles will have the same phase, crest or trough. Okay, so phase also gone. All right. Then net magnetic flux through any closed surface, because always this is Gauss's law, this will be always zero. This is because there is equal amount of north and south pole. So whatever line goes out will automatically come in. So there is no flux leaving or entering in net. So it is always going to be zero. Light, when it interacts with matter, the packet of that light is basically called as photon. Isn't that right? It is basically called as a photon. Very good. Awesome. Then what else is remaining? A molecule which possesses permanent dipole moment. What is it called? Yes, it is going to be called as polar molecule. So this is also done. All right. Not all of them might be useful. Some of them might just be chumma there over there. Polar, zero, phasor, phase, photon. Correct. Polar, zero, phasor, phase, photon. Perfect. We got it. Loving these sessions. Make sure you are liking it. This is the next question coming up on your screen. We have been doing this question 100 times. What are the basic properties of charge? One of the properties you can say it is conserved. One of the properties you can say it is conserved in an isolated system. So the net charge initially will be the net charge finally. Then the next you can say quantization. Next you can say quantization. So charge is always integral multiple of E, where E is 1.6 10 to the power negative 19 coulomb. This is what you can write. If more properties are asked, then you can say it is a scalar quantity and the unit is basically in coulomb. So all these things you can write down. Sir, yeah, okay. I hope this is clear. Yes, additive. Yep, it is quantized. Perfect. Uh, Prabhu, the thing is, not many students were interested in the KCT classes. Students were telling that they have preparatory, they have practicals, they want to focus on PU. So that's why. See, guys, when we put in so much of effort, we what do we want? Are we asking for 1,000 rupees or 2,000 rupees or anything? Nothing. We just want you to see our videos. That's all we are asking you to do. So if you don't see it, and we invest a lot of time, because remember, we're also teaching on JEE NEET channels, and we are also sacrificing a lot of things. So we want you guys to watch it. Okay. So if you don't show that thing, then we'll feel that okay, maybe you are not interested in it right now. Maybe we'll have to do it later. That's the reason why we had to stop it. Next, what is the expression for drift velocity in terms of current? Explain the terms used. Okay. Moving on. Drift velocity in terms of current. Current is equal to NVIDIA. That is the formula. Current is equal to NVIDIA. This is the formula. So VD is equal to I by NEA. Now, what are these terms going to be? This is obviously the current. This is basically the area of cross section. This is 1.6 10 to the power minus 19 coulomb. This is number of free charge carriers per unit volume. Per unit volume. These are the terms, and you can mention that this is, you can show the diagram for this. That will be better. You can show something like this. This is a wire. This is area of cross section, and then you can show these charges like this. These charges are basically your electrons, and these charges will be moving with a velocity of drift velocity, and at the same time the current will be going like this. If you show this diagram plus this, no way the examiner can cut even half a mark. Okay, the examiner will be super impressed. Oh my God, this student knows everything. He's shown the diagram also. Cool? Awesome. Yes, I'm doing marathon on JEE channel also. Like, I don't know whether you know this, we also have a JEE English channel, okay, and NEET English channel. So right now, if you see on the Vedantu JEE English channel, we are doing all marathons and all that. Like, I'm doing complete physics, Diksha, I'm doing complete chemistry, Navratam, I'm doing complete mathematics, okay. NTS favorite questions on Monday. Today, we had the 99 percentile questions, which went really well. The PYQ classes, even the notifications, the easy kill questions, difficult questions, high weightage questions, most expected questions, PYQ series, everything is there on the JEE English channel. Okay, so if you want, you can definitely check it out. It will be very, very helpful. All right, moving on to the next one. We have planned Prabhu, one KCT class next week for question practice. Next week, just like we did 100 questions KCT, one more similar class which will help you for JEE also we have planned. Okay, so KCT plus JEE combo, we are planning it next week. In fact, it will be there very soon on Monday, Tuesday, the session will be live. Okay, awesome. Write the expression for speed of light in terms of mu naught and epsilon naught and explain the terms used. The speed of light formula will be given by 1 by root of mu naught into epsilon naught. This is nothing but your permittivity. This is nothing but your permittivity of free space, which is having a value of 8.85 into 10 to the power minus 12. This is nothing but permeability of free space, which is having a value of 4 pi into 10 to the power 7 SI units. After substituting, the value of the speed of light comes out 3 into 10 to the power 8 meters per second. This is what you should write down. If you write it, 100% you will get the full marks over here. Okay, same thing which has been mentioned. Okay, this root symbol, and they are in the denominator. Keep that in mind. All right, moving on to the next one. Write the ray diagram for the formation of image in case of a simple microscope. Now, main things which you should remember for a simple microscope is that the image is going to be virtual, number one. It is a microscope, so it has to enlarge it, so it will be enlarged. and it will be also erect. It will be also erect. And in this case, the object which is there, where will you place the object for a convex lens so that these kind of images are formed? It will be between the focus and the pole. That is where that object will be, between the focus and the pole. So if we try to draw this particular diagram, it will look something like this. Okay, like this. And the object might be here, let's say. This is your object, and maybe this is your focus. If this is your primary focus, same distance over here, this will be your secondary focus. So if you start showing the lines, ray diagram lines, it will look something like this. One ray will go like this, parallel, and after it is parallel, obviously it has to pass through the focus. So it will go like this. And any ray which passes through the pole will go undeviated. Okay, it will go undeviated. So what I need to do is extend these lines in the backward direction, something like this, I believe, and they will intersect somewhere. So wherever they intersect, that is the exact location where the image will be formed. So this is the location where the image will be formed, and the human eye will be present over here. So you are seeing through the convex lens like this. You're holding the glass like this. You're holding the glass like this and seeing this object. You are seeing a magnified image over here. Is that okay? Show this, mention this and this. You will get full marks. That is what has been done over here also. Is that okay, everyone? Clear? All right. Awesome. Awesome. Only marathons, how many marks can you expect? See, if you attend all my mock tests and marathons and you practice the questions after that, I'm telling you 90% will be easy. I'm pretty sure if you have done decent portions and at least those high weightage topics and you have practiced all these models, 95 to 99 percentile is possible just by these YouTube classes also. Okay, but you have to practice a lot. You have to do it on your own. High weightage topics which I have mentioned on the J channel, also please do it. Okay, cool. Moving on to the next question. What is diffraction of light? What is diffraction of light? You can show examples. It is basically the bending of light. And when does it bend? When it passes through holes, corners, etc., slits, and all of that. So you can show things like this. Say this is a corner, and if light was traveling like this, then it will basically bend. So you can see light is bending. These are the rays of light. Or maybe there was slit like this over here. So maybe the light was going like this, maybe. So after this, you will see it will behave like another source and the light will bend. So you can see that the rays of light are definitely spreading out. So that is basically the diffraction of light. Okay, simply put, bending of light near edges of an obstacle or a slit spreading into the region of the shadow is known as the diffraction of light. Okay, actually, the light shouldn't have gone here. This should have been a shadow. It should be a dark region, but still the light has spread. That is what is diffraction. Okay, very good. Write the expression for de Broglie wavelength of electrons in terms of electric potential and explain the terminologies used. Explain the terminologies which have been used. De Broglie wavelength. The de Broglie wavelength has a formula, Planck's constant by the momentum. Okay, so let me mention what is this. This is your Planck's constant, and this is nothing but your momentum, and this is your de Broglie wavelength. This is your de Broglie wavelength. Okay, and you have to write it in terms of electric potential. Okay, so what we can do, h by momentum. Momentum is nothing but root of 2 times mass times kinetic energy, and this is due to the fact since kinetic energy is square of the momentum by 2m. square of the momentum by 2m. That is the formula. So 2m into k is p square. So p will be root 2mk. Then you can write this as root of 2m kinetic energy as charge into voltage. Charge into voltage. So that is the final formula. So over here, this is basically the mass, and this is basically the charge, and this is the potential difference by which it is accelerated, by which it is accelerated. That is what it is. So if you write this, full 2 marks will be granted to you. You will be impressing the examiner. Is this clear? All right, all right. Sir, can I just see that marathon? No, just don't see that marathon. Also see the mock test questions. Don't just see marathon. See the mock test also. Very important. There are PDFs. Download those PDFs. Solve the questions. Whichever questions you are stuck. See the teacher explaining the solutions for physics, chemistry, mathematics. Distinguish between N-type and P-type semiconductor. What is the distinction between N-type and P-type of semiconductor? We have done this many times. N means electrons, P means holes. Excessive electrons is in N-type, P is having excessive acceptor, basically holes. N will be doped with, pentavalent impurities. P will be doped with trivalent impurities. So in p-type, the holes will be more than the electrons. Trivalent impurity, because trivalent means it will try to have one more electron from somewhere else. It will be accepting those electrons to make those 4 bonds everywhere. Holes are majority as compared to the electrons. N-type, electrons are more. Electrons are majority charge carriers. Pentavalent, there is penta. Penta means 5. So one electron is extra, so it will easily donate it. Okay, so these are the main differences between p-type and n-type. If you write this, actually don't write it like this, write it sideways. I wrote it point wise, one below the other. P-type you can put here, n-type here, put as points. Examiner will be super duper impressed. Okay, very good. Okay. If you've not studied anything for JEE, then I would suggest that, okay, watch that marathon and only do high weightage topics. Only do high weightage topics. Just do that much. You will get 90 percentile. Okay. Next question. Derive an expression for potential energy of electric dipole placed in a uniform electric field. This is again a very standard but important question. Let's have a look at it. How do we do this derivation? First of all, let us just say this is a electrical dipole. Okay, electrical dipole like this. So this is your electrical dipole. So this is yeah, this is your positive negative charges. And let's say the electric field is in this direction. This is your electric field, and they make an angle between them. Let's say I call it as theta. Now whenever we define electrical energy, we need to define some state as zero energy, and all the energy should be mentioned with respect to that. So usually what happens, we define a zero energy state. We define something called as a zero energy state, zero energy state for reference purposes. Potential energy is always measured with respect to something, where we treat the potential energy to be zero when the electric dipole moment is perpendicular, when the electrical dipole moment is basically perpendicular to the electric field. So theta will be 90 degrees. Excuse me. That's when the potential energy for that 90 degrees is going to be 0 joules. This is considered as the reference energy or zero state energy. Very, very important. You should mention this, otherwise the derivation will be invalid. Now, in order to find that energy change, potential energy of that dipole, find out the work done, and the work done is integration of torque into the angular displacement from initial to the final value. Work is force into displacement. In rotation, it is torque into angular displacement. Is the torque value known to me? Yes. Torque is electrical dipole moment into electrical field into sine theta into d theta. Initial to final, let's say the initial is at 90 degrees, the final is at some theta value. So this will be P is sine theta d theta. So P is a constant, electrical field is a constant. So integration of sine theta is minus cos theta. Minus cos theta minus 90. Sorry, why minus 90? Just 90 degrees, and this is theta degrees. Okay, so this will be PE. First put theta, so it will be minus cos theta minus, then put 90, so minus cos of 90 degrees. Cos 90, what is cos of 90, my dear students? Cos of 90 is basically going to be 0. So anything minus 0, forget it. So this will be minus PE cos theta. But you can also do one more thing. Let me just duplicate this and put it on the next slide. Whatever work you do will go into the potential energy. Whatever work is done will go in the electrical potential energy of that dipole. So therefore energy will be the W, which is negative P E cos theta. But P is a vector, E is a vector, so and cos theta is there. So you can also write it as P dot E, that's it, a dot product. So this formula is the expansion, this is the dot product formula. So that is the expression for energy of a dipole placed in somebody else's electric field. Is that clear, everyone? Perfecto. So all this is there over here also. And have they mentioned anything else to be derived? No, that's it. If you want, you can mention these things, that potential energy will be minimum and it will be minus PE when cos theta is 1. That means theta is basically 0 degree, and theta is 0 degree. And potential energy will be maximum and it will be plus P when cos theta is negative 1. That means minus minus will become positive. So that will happen when theta is 180 degree. So these are the minimum and maximum values. Remember, it is going to be 0 when theta is 90 degree. So negative for 0, 90 degrees will give you 0 energy and 180 degrees will give you plus P energy. That's how it is. All right. Moving on to the next. Write the expression for the force per unit length between the two wires carrying current of infinite length. Hence, define the SI unit of ampere. All right. So here is how it goes. Imagine these are two wires. Visualize them in 3 dimension now. Actually, these are two wires. They are infinitely long. This is wire carrying current I1. This is wire carrying current I2. The wires go till infinity, by the way, starting from infinity like this, and they will develop magnetic field around it. The magnetic field will look something like this, maybe like this, maybe. So just imagine this. Okay. If you hold the fingers of your right hand such that the thumb goes in the current direction, the fingers show the direction of the field. So the magnetic field is going to be clockwise. So I will obviously have to show clockwise magnetic fields. Okay, so this is the magnetic field. If you consider this particular wire, by the way, let's assume that the distance between the two wires, is basically d. So at this particular point, if you ask me what is the magnetic field, it will be downwards like this, and that magnetic field will have a value mu naught. It is because of this current, so I1 by 2 pi distance. Distance is basically d, and the magnetic field is downwards. Please mind it. Visualize this in 3 dimension. Whenever magnetic field interacts with a current, it produces a force called as ILB. Current is in this direction and it is a cross product, length cross B. Length is here, cross it with the magnetic field. My thumb is going this way. So you will see that the force will come out like this. The force will basically come out like this. This force is nothing but, this force is nothing but current which is passing, in this case it is I2, into length cross the magnetic field. Cross the magnetic field. The best part is this cross product will not even matter so much, because I'll tell you, cross means it is sine theta. Here length and the magnetic field are perpendicular, so sine 90 will be 1. So don't worry about it so much. So therefore the magnitude of the force will be nothing but I2 into L, and the magnetic field we just wrote it down here, mu naught I1 divided by 2 pi d. Rearranging it further, I will get force per unit length is equal to nothing but over here mu naught by 2 pi, mu naught by 2 pi, and here we'll have I1 is there just from here, just the same I1 I2 over here, whole thing divided by d, whole thing divided by d. From this, we have first of all found out the expression for the force per unit length between two wires carrying current separated by distance d. How to define SI unit of current? So you can say, if 1 Newton force acts per 1 meter of a wire such that there are two long wires carrying the same current, and they are separated by a particular distance. Okay, they are separated by a particular distance. Now what you can do is this mu naught by 2 pi, we already know this particular value. See, if the current has to be 1 ampere, this is also 1 ampere. This particular value right over here, because mu naught is 4 pi into 10 to the power 7, right? So what should this be? This should be nothing but 2 into 10 to the power 7 right over here. Is that right, everyone? Yep. And if this distance happens to be, if this particular distance happens to be, such that both these currents are 1 ampere each, then this distance has to be exactly cancelling out this number over here, so that you will get the currents as 1 ampere. So that is what you will write it down as simple as that. So 1 ampere is that value of current which will maintain in each of the long wires parallel conductors placed in vacuum produce these currents, which produce these particular forces. So put the distance in such a way that it will cancel out with this value. Force is 1 Newton per meter. So I1, I2 should be 1 ampere. That's all. Okay, everyone? Great. So now, next question, distinguish between dia and ferromagnetic materials. Yeah. All right. Come on, my dear students. Distinguish between dia and ferromagnetic materials. What is the distinction? Diamagnetic and ferromagnetic. Diamagnetic, first of all, the relative permeability is less than 1. For ferromagnetic, the relative permeability is more than 1. In fact, it is much, much larger than 1. In fact, the susceptibility is very, very positive. Here, the susceptibility is less than 0. It is basically negative. It is negative. Diamagnetic materials, they repel the field. Here they basically are attracted, and not attracted normally, they are strongly attracted. They are strongly going to be attracted. Is that correct? They increase the net magnetic field which is passing through them, whereas diamagnetic, they reduce the magnetic field. They reduce the field which is passing through it. Is that right? Correct, my dear warriors? Not just that, these magnets of diamagnetic materials, they are temporary magnets. They are temporary magnetism is exhibited, whereas ferromagnetic materials exhibit permanent magnetic behavior. So all the permanent magnets are made of ferro. diamagnetic materials are temporary in nature. So all these things are again mentioned. I had mentioned many more points. So you can mention 2-3 points so that you will get those full marks. Better to mention one extra point to be on the safer side. Is that clear? Okay. I'm so glad, Girish Hegde. I'm so glad it is helping you. So we have done 30 plus questions, and I will do one thing. I will put more questions in the PDF so that you can benefit out of it. Okay. This is one last question which I might do. Expression for the torque on a dipole placed in a uniform external field. So this is again just like what we did over here, finding the derivation for potential energy. Similarly, I'm doing it for the dipole moment torque. So imagine this. This is your dipole moment, negative, positive, and the electric field is acting like this. This is the electric field, and let's say this is theta. So the electric field will apply electric force on the positive charge like this, and on the negative charge, it will be opposite to it. So the force magnitude on the negative charge will be charge into electric field. The force magnitude on the positive charge will be Q into E. The length of the dipole is, let's say, L. Now these two forces, if you calculate, the net force will be zero because they will obviously cancel each other out. But net torque will not be zero. In fact, they behave like a couple force. A couple force is where there are two equal opposite forces separated by distance, because of which they might cancel force wise, but torque wise they will rotate it. So there is definitely rotation which will be observed. So therefore definitely there is a torque which is there. Now to find out the torque, you can choose any point to measure the torque. Let's say you try to measure the torque about this point. All you need is R perpendicular into F. R perpendicular means on the force, drop a perpendicular. On the force, drop a perpendicular. Force is like this. This is your line of force. On that force, drop a perpendicular. So as you can see, this particular distance, which is going to be called as R perpendicular, is nothing but the height of the right angle triangle. This particular length, obviously, this particular length obviously is L by 2. So if this is theta, naturally, even this angle is going to be theta, and this green side is opposite to theta. So therefore, it should be the sine theta component. So it will be L by 2 sine theta. Same thing I can say over here. Even this is basically R perpendicular, and it will be L by 2 sine of theta. Now, in order to find that torque, the torque will be R perpendicular into that force plus R perpendicular again that force on the negative charge. On that negative charge. Torque because of this force, torque because of these two forces. So they both will add and produce the net torque. They will produce that net torque which we want. Okay. So how much is R perpendicular? L by 2 sine theta. What is that force? It is basically Q into E. R perpendicular again L by 2 sine theta. What is that force? Again it is Q into E. Half plus half is 1. So it will be L sine theta Q into E. Let's rearrange this and write it in a slightly better form. Like, for example, let me write charge into length together. Let me write electric field separately. And finally, let me write sine theta over here. Well, sine theta is sine theta, no problem. Electric field is electric field, no problem. What is charge into length? That is dipole moment. So basically, we got that the torque is Pe sine theta. But if you write it in vector form, this is vector, there is sign in between them. You can put a cross product and you can put electric dipole moment vector, and here you can put electrical field vector. So this is vector form, this is the magnitude form. So that is the simple derivation of this. So if you want, again watch the replay, you will get a hang of it, so that you practice it 2-3 times, you will definitely get it. Okay, so that is what this is. Awesome. Write the expression for experimental observations of photoelectric effect? Well, there are many observations. Like when light is incident of a certain frequency and above, only then electrons are emitted. Below the threshold frequency, no electron emission occurs, no photocurrent is exhibited, even if the light intensity is increased. Also, when photoelectric effect occurs, when you increase the light's intensity, then it is found more current, more electrons are ejected out, showing that intensity is directly proportional to the current. Is that right? So these are some of the observations. There exists a minimum frequency above which photoelectric effect occurs. The maximum energy of the electrons increases as the frequency of the light is increased. So if you put more frequency light, higher energy light, the electrons also have higher kinetic energy. And above the threshold, maximum energy depends only on the frequency of the light, and it is independent of the intensity of the light. The intensity only decides the current, not the kinetic energy. These are the pointers which you can mention. You will get full 3 marks or 2 marks for that particular question. Write 3 postulates for Bohr's atomic model. Bohr's model was a development over the Thomson's and Rutherford's model, and it also overcame some of the limitations which the earlier models had. Start with this statement. Examiner will be super impressed. Then mention, although Bohr's model had certain more limitations, but still it explained the behavior of simple atomic models, and it laid the foundation for atomic structure in detail. So the sum of the postulates are as follows. Then what are those postulates? You can write. Atom has a stable orbit in which the electron can reside without emitting or accepting any energies. It can just stay calm. Okay, it will not lose any energy, nor will it, chumma randomly take energy from random things. No, it will just be stable in those orbits. They are called as stable orbits, and each orbit has a fixed level of energy. But when an electron accepts the energy from photon, it can only jump if the photon has exactly that energy for it to jump to the next energy level. And an electron can jump down to a lower energy, and it will emit a photon in that case of exactly that energy difference. That is what is very important. Again, the motion of the electron in circular orbit is such that it is quantized in nature, and the angular momentum is multiple of h by 2 pi. L is nh by 2 pi. Write this formula. Delta E is hf. Energy difference is hf. F is the frequency of the photon. And stable orbits, fixed energy without any kind of emission, any Maxwell's radiation does not occur. If you write these postulates, full 3 marks. Okay, very good, awesomeness. Explain conduction band, valence band, energy gap in semiconductors. Okay, explain conduction band, valence band, and energy gap in semiconductors, my dear warriors. Conduction band is where it is just above the valence band. It may be partially filled or completely empty. Okay, and it is conduction band because they contribute in the conduction of electrons. When a potential difference is applied, these electrons in the conduction band, they begin to move and participate in the conduction. Hence, that band is called as conduction band. It's a range of energies which is, basically of all the atoms in that solid, and all these atoms, electrons, which are not in a completely full orbit, or not in a completely filled orbit, sorry, not full, filled orbit, those electrons contribute towards the conduction band. So they are not completely satisfying the valency of the orbit, they are partially filled or completely empty. So that is basically your conduction band. Valence band is where valency is complete. All those electrons which complete the orbit, satisfy the valency, when they interact, they form the valence band. They are just below the conduction band, and they do not participate in the basically conduction of electricity. Okay, perfect. All right. Moving on, what is band gap? Band gap is basically the energy difference between the valence band and the conduction band. That is called as the energy gap. If this gap is very less, electrons can easily jump and it will behave like a conductor. If this gap is too much, then the electrons can't jump to conduction band and then it will behave like a insulator. So that is your energy gap. All right. So these were some of the questions which we had to do. Okay. I hope this is absolutely clear. Like I said, anything more needed? I mean, I'll be putting the PDF obviously. More needed, please put it up in the comments. Please smash the like button, share this video with your friends, subscribe to the channel. And next week, I'll be doing a KCT JE mock test for all of you. It will help you in KCT plus your upcoming JE examination. Okay. Take care. Have a great time. Bye bye. Captain Shreyas signing off. Hasta la vista.